All right. Recently, I implemented something called Zobrist hashing, where I um, tried to build a hash table structure, data structure, which allowed me to hash sets of integers, really. But the concern that I have at the moment is that uh, in order to somewhat efficiently compare two sets and make sure they are equal, I have had to enforce um, an ascending order uh, constraint on these sets. So they're not really sets; they're just arrays that I'm very specifically trying to make sorted. So I thought, in order to further this, I had to actually um, have a set data structure, like an actual hash set structure. For now, I plan on just keeping it to integers. I don't really want to have to deal with generic types right now. But I mean, like I have like a dynamic array macro, right, which lets me sort of generically type my dynamic array. I want to do something similar eventually with the hash set and be able to store whatever I want. The only issue with generically typing is I would need to also generically type like different. Like, I need different hash functions for different types because like the way you hash a integer versus the way you hash a string will likely be very different. Um, so yeah. Um, cool. So yeah, let's just do that. I've read a little bit about like how Python implements sets. There's this guy's article. I read through this, but this article didn't talk about how Python iterates through sets. I know that they use like the iter or iteration kind of thing, like it transforms into an iteration, like the set into an iteration that it can use the next method on to get the next element, but I don't really know how it works under the hood. So I'm just gonna like leave it for now and just do it how I think it would work, and then I can do proper research after. All right, so let's make a main, and as usual, yeah, I'm not going to structure anything correctly. I'm just going. Wait, no, do I have a correct branch? Yes, I do. Okay. I'm not going to structure anything correctly. I'm just going to write everything out, and then eventually I will do it correctly. Whoops. Okay. So we have our boilerplate, and then so yeah, I want to create. What do I want? I want a hash set, which in essence will store a bunch of integers. Might even use my dynamic array. And normally I've seen that there's like counters for num elements and like total size, and is that enough? Surely that should be fine. So like total size refers to how big the overall hash table is, including all the empty slots and the tombstones and everything. And then int num elements is just like the uh, number of active elements, legitimate elements that exist. I think I also need like, oh my god, I also need the, I need a structure that stores like like the value of a key, the key and maybe its hash as well. Yeah. So like ht item we'll call it. In fact, these should all be somewhat capitalized. So like this will have the key, and also it will have the hash, which I guess would be 64-bit or Do we care? We'll just keep it as integers for now. So in fact, this should not be integers. This should be a hash table that stores a bunch of hash table items. And yeah, this is basically like a caching idea. Like you might have to hash a key once, but then the idea is once you do it once, hopefully you don't have to do it again. So like especially when you're resizing, to resize the array ever because you got too many elements, you can use the hash that you've already calculated in here to reposition the item in the bigger hash table. So that's cool. And then there's like a rule about, not rule, there's like a guide about like, you never want your hash table to be super full, but you also don't want it to be like really, really sparse because that's like a waste of memory. So I think there's like a fraction, like 3/4 full or something. I don't think it's half. Half feels like it's too sparse still. I think it's like around 3/4. So like when the hash table gets 3/4 full. Wait, is that 3/4 including the tombstones? Do I have to count the tombstones? I don't know actually. Surely not, because like I'll just replace the tombstone if I come across it, right? No, I can't do. Wait, can I do that? If I want to insert an element and I replace a tombstone in doing so, when I want to look up another element, yeah, it should be fine. It should be fine. Okay, I think it should be fine. When the hash table is 3/4 full, we will double the size of the hash table and reposition everything. Assuming we're using the same hash function, the hashing itself will be the same, so this value will be the same. But where things get positioned might change because when you mod it with the size of the array, now that the array is doubled in size, when you mod it, it might change the thing, I think. What else? When the hash table gets 3/4 full, we will double the size, and we'll use linear probing. I'm going to use basically, I've seen that apparently Python uses like some mixture of like linear probing and like a bit more randomized probing and like some cool stuff, which is cool, but I'm not doing that. Yeah, number of elements, total size, that lets me figure out how much of it is full, and then also an array that lets me scan through everything. Okay, so let's say I want a function called hash set star hash set init, and I guess I've seen that Python like sort of roughly starts with eight elements in the hash table, like 8 slots. I mean, I don't know if that's like a good idea, but we'll roll with it. Hash set min size or start size. So we have all this hash set in it. I don't think I need anything, right? I'll just malloc. So hash set star equals malloc size of hash set. Don't get that wrong. And then hs ht. This is the actual table, the hash table. Equals malloc size of ht item times the hash set min size. So 8 of these. I normally put this guy at the front. Whoops. Okay, so we have that, and then int. What have I done? hs total size is equal to that hash set min size, and hash set keep hitting the 0 num elements is equal to 0, and then we can simply return. How fun, right? Nice and simple. So doesn't need much, just getting the address to that hash set. I think one of the things that Python does do is, because the hash set starts quite small, with eight slots in it, they actually use like the stack, I think, and allocate the memory, the array memory on the stack. And only if it gets sort of bigger do they actually start using the heap, like mallocing and stuff. But that's more food for thought than anything. And then, yeah, I guess hash set. Like, I want to deal with this resizing thing straight away. So given a hash set, given the hash set and given nothing else, I think that's all I need, right? So if hash set num elements over hash set total size is less than 3/4. Well, this will do not the correct division. This will do integer division. So if I do like 1.0 or something times, will that work? If this fraction is less than 0.75, then return HS. There's no need to do any resizing. And there's no need to have braces here and here. Actually, just in case, sometimes I've had issues before where I've forgotten I've done that. Anyway, so we have return the HS because we don't have to do any resizing. Otherwise, how do I resize stuff? If I use realloc, is that fine? I need the standard library actually, now I think about it. Okay, wait. So realloc, the pointer and the size. Total size times 2. Shifted by 1. So I think, I'm pretty sure everything stays preserved. Like under the hood, it will do what it has to do in order to make sure I don't lose anything. HS equals that, right? Because that returns the pointer. And then we do all that. HS total size doubles. And I have to reposition everything. So do I have to calloc this then? Make sure everything stays as null? Because the number and the size. Yeah, I think I'm gonna calloc there just in case. If for int I equals 0, I less than the hash set total size. So this is like an instance where I'm iterating through the set. If the hash set hash table, oops, I need brackets. If the hash set hash table at I, if it's a null, then just continue, because it's an empty space. Oh, I need tombstones actually. I forgot about this. So, oops. Okay. Tombstone tells me if it's an element that's been deleted. If hash set, what's wrong with that? Expression must have an arithmetic. Am I tripping out? No. What? Did I not? Hash table at I. Because it's pointing to hash sets, which is the actual struct. Right? Hold up. So the hash set, I dereference it and get the hash table, which is an array that stores hash items, which aren't addresses, so I can't compare it to null. So if I make it like a double thing, if I say you're a array that stores hash item pointers, is that fair game? Yeah? Okay, that should be fine now. Yeah, so if it's null, else if this tombstone, if it is a tombstone, then what you have to do is you have to free that particular element and then make the thing equal to null. So eventually you should hs ht at I should equal null, but before that you want to make sure you free the resource. So hs ht at I, gotta free that. Was there anything else I have to do? Not for now. Maybe it's best to have like a free function for each struct, just in case, like if this extends and becomes a bit more generic, maybe, you know. Whatever, actually. If it's a tombstone, free that item and then set this guy to null so that it's kind of a free space again. Else, if it's there should be an active element at this point. If it's not an empty slot and it's not a tombstone, then it's an active element. So int index is equal to alright, here we go. It's equal to hs ht at I, get the hash. So this hash value is going to be the same because it's independent of the size of the array. And we're going to mod it by the table size, which is the same thing as anding it with the table size minus 1. Where table size, of course, is derived from total size, sorry. So this is the same as modding by the table size because the table size is a power of 2. We're setting it so that the size starts as a power of 2 and then we move from there. So the index is that. hs, the hash set hash table at the index is equal to, what's wrong with that? Oh, semicolon. hs ht at this current I, and hs ht at the current I should be equal to null. What if it happens to be the same number? Will that screw me over? Temp equals hs hti. So I'll just save that address. What is this thing again? ht item temp. So set this to null and then make this temp. So then we're repositioning if required. And we do that for every element. And then we also make sure we double. I should do this before I do anything else. So you realloc and you do this. Number of elements stays the same. Tombstone stuff gets removed because it's like a nice pit stop. And then we reposition everything based on same hash but new size. So the index, the modding has to change. This is cool. This is fine, I think. Reset this and then set this to temp. Okay. And then eventually, after you've done with that for loop, you should just return the hash set that you realloced. Okay. I felt like hash resizing might be a bit annoying, so I thought I'd just do that. Now, hash set. I need a function. I need a hash function actually. For integers, I've seen that apparently hash set hash int some key. I've seen that apparently apparently just returns the key. For integers specifically, the Python hash function just returns the key. We can beef that up a bit more if we want, but I mean, I'm happy to do that. Remember that the key is not the actual index. Like the hash result is not the actual index yet. We're still gonna do the modding stuff to make that happen, but for now, I guess yeah, void hash set add, given a hash set pointer, and given, what do I want to give? I guess a key, just the integer, right? The key. Yeah, so if you were to make like a generic macro out of this, a lot of stuff would have to kind of be generalized, all the ints everywhere and stuff like that. But for now, keep it as integer sets. Hash set add so the I guess I should check for the existence first. So check for the existence of this key. So like look it up. And if it's not found, then wait, let me do this actually. Check for the existence. So I need to get the hash. I need to get the hash, which is hs hash given that particular key. And then I have to get the appropriate index, which is the hash ANDed with hs total size -1. That's the same thing as modding by the total size. And then for int I equals index, I less than hs. Well, actually, if I try to do this a similar way that I did the other thing, for int count equals 0, count less than hs total size, count plus plus, we'll have a, call this start, and we'll call this index. Whoops. At the end we'll index plus plus. But before that, you'll say if this hash table at the index, if it's equal to null, or, so this is I think similar to my Zobra stuff, or it's a tombstone, that I think you can break out or something. Because that means you found the actual spot, you know? You found the place where this thing can be added. Else if hs ht at index key, if that's equal to your key, then index equals maybe just a boolean. So if it already exists, it is a hash. It's a set, right? So I don't need duplicates. So yeah, if it's null or this one, then that's fine. If it already exists, then that's also fine. Otherwise, bump this up. I also have to say, if index equals to the HS total size, then it's no longer a valid index, so I have to bring it back down to 0. I have to make it wrap around or something, which is a bit annoying, but I don't know. Again, just doing this really naively. Alright, so yeah, we loop through. If it's like that, then it's fine. Is it fine? Am I doing this correctly? Void. What am I doing? What? No. So if already exists, then return. If, I mean, the second thing should never happen. If the count equals the total size, which should, again, it should never happen because the because I'm going to be doing the resizing thing every time we add something. But just in case, if the count, oh wait, if the index is back to the start, can I say that? Like if it's wrapped all the way around once, then just resize, I guess. So I guess I have to return the actual, just in case, if I end up resizing it, maybe I'll need to. I shouldn't call it just resize, I should call it hash set resize. Given the hash set. Maybe I should just do this at the start. If the, so I'll have like a hash define max fullness cap is 0.75. And then if the hash set, so then yeah, maybe it is better to keep track of the number of tombstones as well. Number of tombstones. Okay, number of elements refers to number of active plus number of tombstones. I think that's the number I want anyway. And then num active is just the number of active only. HS. I don't know if I need to know that, but it might be nice in case you have like, if you want to get the size, you know. Okay, so num elements is tombstones and active. Just because I think because the fullness thing, it is full if there's a tombstone there, you know. So if HS num elements divided by hash set total size, and again I think 1.0 times, or make sure that stays as a float. If it's greater than or equal to the max fullness cap, we'll say equal to as well, then do this. Yes, and because of that, we shouldn't need to be too concerned about like it being too full, you know. Should be fine. Int start equals hash, so you got the starting thing, blah blah blah. No, delete all of that. If it already exists, then yeah, for sure return. Otherwise, we should have a value for the index that gives us a nice empty spot, right? So then otherwise, malloc size of hash table item star item equals that guy, item tombstone equals false, item hash equals the same hash as before, item key is equal to key, and the HS hash table at this index that we found by doing this linear probing business is equal to this item. How fun. Okay, now we need to do a lookup. Hash set. Oh, I need to return as well, actually. Return the HS, again, because of that resizing issue. Hash set. Not hash set, boolean. Hash set lookup. So this is purely true if it exists and false if it doesn't. So given a particular hash set and given a particular key, so yeah, start is exactly the same. So the fact that I'm copying and pasting indicates that maybe I could be a bit less redundant. In fact, this for loop will also be very similar. I'll write it out, but boolean found equals false. Boolean already exists. Yeah, so for int count equals 0, count less than total size if, so yeah, sorry, int index equals start if index is no longer a valid thing, then index equals 0, and then from there if htable, if that index, oh sorry, first if it's null, then return false, I think. If you hit a null, like properly, then it's supposed to mean like, oh, you know, this key that exists, this key that you're looking for, would have been on this null if it existed, so you can return false straight away. That's why you have to be really careful about tombstones. You can't delete them straight away. You have to sort of wait until you rehash everything. Hang on, I just realized something. Hash set add relies on hash set resize. But then hash set resize relies on hash set add, doesn't it? Oh no, I don't use it. Oh, but there could be collisions still, so this needs to handle collisions then. Okay, I need to be a little bit careful. Does not handle collisions correctly. This section doesn't really do that. Okay. If the hash table index is null, then return false. I could just say not actually, but for now I'll just say it's null because I feel like that's more indicative as to what's happening. If it's null, then return false. Otherwise, if hash set index hash table, sorry, index tombstone, if it's not a tombstone, and key is equal to this key, then return true. Again, I don't need. Wow. If it's that's the only two cases, right? If it's null, I can return false. If it's the actual key and not a tombstone, then I can return true. If it is a tombstone, I have to keep looking. And yeah, that should be it. The hash table is not a tombstone, and the hash table index key is the same key, then I can return true. Okay. And then if we get out of all this entire thing, I need to also ensure that index gets incremented actually. If I get out of this entire thing and I haven't done anything, then I should return false. Because I would have returned true by now if I could. Alright. So I have it exists. Now I should really think about I want to say that I can do this. I want to say that I can be like, if I forward declare this, like if I give the function prototype for this, then instead of doing that whole thing in the resizing, instead of doing all this, oh, I don't know actually, maybe I shouldn't do that. I was gonna say I could use the add. Maybe a mixture of using like the delete function and the add function. Given HS and given something. Yeah, but I feel like this is wrong actually, the resizing. Because like for each element, I'm doing one at a time. I'm taking it off and putting it back in. The concern is like, what if because of an old element, there's a collision, right? And then I try to put that. Okay, wait, let me draw this out. So my concern is when I'm trying to resize, the reason why I would have resized is, I have 1, 2, 3, 4. It's like 2 full, right? Maybe there's one more. So then 1, 2, 3, 4, 5, 6, 7, 8. I'll put 2 more, just to make it like power 2. 1, 2, 3, 4. We'll say like 5, 6. Right? So 6 out of 8. And then let's say, so it doubles, or like draw it in red, doubles with another 8. So 1, 2, 3, 4, 5, 6, 7. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. I'll just chop off the rest. Oh, I forgot it's doing that whole thing again. I accidentally did that. I was not smart. Okay. So then, let's say this guy, I take him off. I take him out. I have to reposition him based on the new size, and he goes over here. Oops. He goes over here, and that's fine. That's no worries. And this guy, he resizes and he goes over here. No worries. But then if I go over here and this guy clashes onto this guy, who is also going to move at some point, then he's going to go here and going to clash with this guy, and then going to get moved over here. And that's going to be his final place. You know, I think we just did this guy. So then this guy, you know, gets repositioned. And this guy gets repositioned. And this, whoops. And this guy gets repositioned. So this dude who got collided with these two guys, those two guys are now gone. So he's over here. If I look for this dude, the hash function will take me over here. I will see a null and think, oh, he's not there. You know, this guy who is in the set, I'm going to think is not there because I'm going to hit a null space straight away. Because the reason he got put over here is because there were old people that caused the linear probing to move it along. But those old people got moved away. So, you know. So I think I have to kind of... I think I have to have a second array. I have to make a separate hash table hash set hs new equals malloc size of hash set total size. This is wrong. This should be size of hash set, but the number of elements should be hs total size by 1, multiplied by 1. I messed something up. What have I done? Why is it like that? Oh, I need an extra bracket. And then from there, all of this, I don't have to realloc here. I have to say that hs new equals hs new. Wait, what? Why is this not doing the thing? Oh, okay. Sorry, this is wrong. Sorry, this is just the hash set, isn't it? This part, hash set, hash item or something? What do I call it? HT item. It's this thing multiplied by that. And hs new, your total size is equal to this guy. Probably save that as a variable, to be fair. Num elements, whoops, is going to be the same as hs num active, because we're dropping all of the tombstones. So the num element in the new is going to be the num active, and the active, num active, is going to be the same as the original active, the num active here. Is there any other fields? Total size I've done 1, 2, 3, 4, 1, 2. Okay, so we have kind of initialized everything. So we're going to return the hs new, and we're going to end up freeing. We're going to have like a hash set free function, and we're going to call it on hs. Okay. So from there, I think it's fair game if we say I really want to reuse my add function, but the add function takes in a single key. But I already have the whole hash item ready to go. I don't want to recreate a hash item here. So what can I do? In fact, I don't even want to free everything in the hash set. I only want to free the hash set thing. I don't want to free everything I don't want to free the internal stuff because... Oh, actually, yes I do. I want to free this. I just don't want to free the items themselves. I want to free the hash set HT I want to free the outer scope. I want to free the outer thing, and I want to free the hash set. But the new hash set will still hold onto the old items. So I'll just write it here because I don't know what I'm doing. So for each, so yeah, if it's null, continue. If it's a tombstone, then free it, and then and then continue. Should free that item because I don't care about it anymore because it's a tombstone. Else, index hs new. So we got a model with that. We get the item. You don't really need to null then. And then for int count equals 0, count less than hash ht new total size. Why is it not like happy with me? Is it? What did I call it? Sorry, hash set, not hash table. For int count equals 0 plus count, we'll say index, increment the index as well at the end, but we'll check if the hash set hash table index is equal to null, then hash set hash table index can equal this item that we've already sort of saved the address of. And we can break out. And because we're doing this in the resize function, there's no need to make we will eventually find a slot for you. Like, we're ensuring that there's more slots than there are items. So this should be fine. I don't need this. For int count equals 0. And if index is greater than or equal to hs new total size, if it's an invalid index, then return it back to 0. So yeah, cheeky double for loop, but hopefully not a big deal. Hopefully. Int index hash table item. Maybe we should call it hash set item. I don't know. The item is get to the hash set, access the hash table, and access the I value, because that's the outer scope. For loop, going through all of the original elements, and then for count, we're just making sure that we actually insert it correctly. Cool. Hash set add. Okay, so if I assume that's kind of correct now, hopefully. I don't really know if I've done that right, but anyway. Hash set add, we hash the key to get a particular hash. We get the starting index by doing this whole modding thing. We loop through until we find an empty spot, and we're pretty confident we will find an empty spot because we resize if necessary. And if it already exists, then return. We have a boolean just to set that. And then otherwise, malloc the item, set all its fields correctly, set the hash table at that index to that item, and should be good. And then this hash set exists. No need to resize anything because we're not adding anything. Hash set hash key int start equals hash, and this one, yeah, sure. So we found is false. Do I ever use this? No, right? Goodbye. If it's null, return false. If it's the thing, return true. Otherwise, increment across. And if you go through everything, you never find it, return false. Okay, so now we can have the delete. I don't think I'll have to actually return anything because deleting won't require any resizing. Well, unless, no, surely not. Hash set hs int key int hash equals hs hash for the key, and then yeah, this is kind of similar because basically doing the exact same thing, except if we manage to find the thing, don't return false, return nothing. We do an exists, basically doing the exist, but when we find it, we also need to set tombstone to equal true, and then we can return out. Bong. Okay. It's kind of badly written, but might work. And then I want to be able to iterate through everything. Void hash set get iterable. I think generally it's not ideal to be iterating through a hash set, but sometimes you can't do much. Should I use a dynamic array for this? I mean, you kind of know how big it is roughly anyway. You know it's somewhere between you know it's at most 3/4 full, so hash set, what am I doing? HS total size. Yeah, that's fine. Int iterable. I guess I have to make it on the actual heap, don't I? Hash set total size, and then size is equal to 0. I don't know if this is worth it, but type def struct hash set iterable, which will have sort of, yeah, the int star iterable and also the size, like the number of elements in the maybe we'll call it that. Nah, that's fine. Okay. No, not instart. Hash table iterable. Nope. Hash set iterable. What the heck? Okay. Sorry. Start, and then the iterable is equal to that, and the size is equal to 0, and then for all the slots, if hs ht at I is a null pointer, or it's a tombstone, then continue. Oops. Otherwise, the iterable at iter size should equal the hs ht at I key. Nope, key. And this will be returning the pointer to that. So we're going through all the slots. If it's a null or a tombstone, don't worry about it. And otherwise, if it is a legitimate thingy, then access it, access the iterable, increase the size when you're done, but access the iterable's next slot, next spot, get the key of the current item and put it in, and then also make sure to increment the size. Cool, and then return the iterable. Okay, should be good. So I don't know how much I've done correctly, but hopefully, if I just start, you know, playing around with it, equals hash set init, and then hash set, and then hash set add. We'll add some, you know, 1 and like hash set 12 and 27 and like a billion. Oh, is that not allowed? You can't do. Okay, I think that's a Python thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, 9. Sorry, I forgot what number I wanted. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fantastic. Hash set add set 40. Yeah, I don't want to make it ascending. I want to make it like random order, kind of like that. Okay, let's try those. You know, 1, 2, 3, 4. There's 5 numbers, so if I do 7, it should have to resize as well. Could also do negative numbers, but whatever. Let me just. Okay. Printf. How do I print a boolean? I don't think that's a thing. I think I'll just put exists 40 equals hash set exists given the particular hash set and given the key, and then we'll try like 5, 1, 2, 3, and we'll try like 6, should be false, and then we'll try like a hash set delete given the hash set and given one of the keys. We'll say 5 for 5. I keep saying HS because I keep seeing that in the. And what I'll also do is I'll say 555 should be true originally, and then if I do this again, it should now be false. And I'll put a print statement in the sizing just to see if it actually happens. Alright. How interesting. I don't use any extra libraries, right? I just use this. Okay, so let me see into the hash set. Do I need anything fancy? No, right? Oh. Return, just return this guy. Yeah, it already exists, return that guy. 1, true, true, false, true, 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 false, true, false. Okay, that's good. That's cool. But did I put a printing thing? Resizing the hash set. It should have done that, right? 1, 2, 1, oops. 1, 2, 3, 4, 5, 6, 7. And the set starts at 8. So yeah, it's definitely bigger than 3/4. Hang on. Okay. So let me just make sure. Did it even enter the function? I'm assuming my guess is that something happened regarding the float number and there's some weird division. Okay, so the fact that this didn't print means it's not being called, which means this guy never ran to become true. Max fullness cap I said was 0.75, so let me just print f what I think would be a float. Checking current fullness proportion, and we'll just chuck that, and the percentage f I want. That's what I'm hoping for. Eh? Oh, right, sorry, my bad. Okay, very good. If I put this in brackets, does that help, or what? No. Wow. I thought it would make this like a float, and then it'd be like a float divided by an integer, and then good things would happen. But I suppose not. Can I cast you? Can I be like float? And then will that be better? No. What if I made you a float as well? Wait, are the actual numbers themselves wrong? Actually, yeah, it's printing at 0.0, so it is returning a float. I don't remember how this works. Something is happening in regards to division. I'm praying that, let me make sure that the individual numbers are correct first, because num elements equals and the total size. Maybe I'm not incrementing this actually. No, that would be why. When I add, I never increment. Whoops. It was nothing to do with the division at all, I think. Num active should increment, as should the num elements in total. I think, right? I had a real logic bug. There we go. Oh. Okay, so yeah, it broke something in here. What do we think? Can I read through my code and figure it out, or do I have to actually debug it again? So I think the 1.0 thing did work, by the way. I think that does work. I just didn't. This was always 0. What happened? Okay, so hash set hs new. So the new guy, we malloc. I'll just put like a set of print statements for now. I just realized I shouldn't. My init function should be a bit more general, so I can use the init function here. Initialize new hash table. Okay, so just put some random ones just to see what happens. Whoa, why didn't we do that? Freeing tombstone from old hash table. slotting old item into new hash set, hash table. Okay. Freeing old hash table. Let's just see if we can, if it helps. Otherwise I'll check a sanitizer and... Ooh, that's pretty good. Got all the way through to there. Freeing old hash table, so printed that, and then this died. And then this, one of these failed? Wait, unless there's other stuff. Maybe this wasn't the problem. I assumed this was the problem, didn't I? It didn't actually, it wasn't actually definitively clear. Oops. Ah, so it did return. Okay, so it would have called hash set resize. I do still think that the hash set resize has something to do with it, but I just don't know what it is. Okay. Maybe I will just use a sanitizer. It's hoping to avoid it, but what can we do? F sanitize equals, we'll say address first. Bang. Heap buffer overflow, which means what exactly? I'm accessing something illegal? Is that fair? Normally if I use after free, it says use after free, right? Like if I do this the wrong way around, for example, and I try this, like it will specifically say use after free, right? Ah, okay. Maybe I did use after free then. Wait, let me try undefined. Maybe undefined. I feel like sometimes when I try the other sanitizer, it like gives me better stuff. Oh, it's this stuff. Maybe it's a size of error. HS new hash set. Yeah, it might be like HS total size. The hash set total size doubled, right? When you shift by one, it's the same thing as doubling. And that's how much I mallocked. Size of item, because the HT is of type... Oh, wait. Should this be pointers? Because these guys are storing pointers, right? Not the actual HT item. The hash table is storing pointers. So it might be that, yeah. Hang on. Because how big is a... Yeah, it might be called... That could be causing some misalignment, to be fair. HS, HT... Yeah, because I'm... Size of HT... What I call HT underscore item, right? This should be fine though, because the item is literally... Yeah, but the... This guy shouldn't be... Like HSHT is storing pointers, so the size should be using pointers. Alright, let me try that. That could be why, genuinely. Never mind. Oh, it was even for that. I did, yeah. Okay, wait. Did we give a thing? 164. Yeah, I feel like, let me just check. If I print index equals percentage %d, hash set num slots equals percentage %d. So you put index and then you put hs total size. Just see what that prints, because maybe that's, I don't know, the way it's reading makes it seem like it's like accessing a bad index, but I thought I, oh wait, whoops. I thought I put the right things. Wait, what? Wait, what? 67. Load of value 64, which is not a valid value for type boolean. Did I make tombstone equals 64? That is a bit insane. But why would it be 60? Why would there even be a 64? Alright, I might need the debugger. Hash set min size. Just to clarify, right? If I didn't deal with 1, 2, 3, 4, let's only put 4 elements, and let's say I check 12 and I delete 12 and I check 12. What happens if there's no resizing? Because that, I feel like this is evidence that's okay. So nothing bad happens if I don't resize. Is that fair? Exists 40 should be true. Exists 525, that should be false. It's still false. Why did I write it twice? Oh, I didn't change this. But 6 also false. Didn't change it here either. 12. Let me just do it again. 12 is false, but before that 12 was true. So something with the resizing, I think, is causing, maybe I initialized stuff wrong in this resizing. Like in the init, I said malloc size of hash set in order to make the hash set. That's good. Then malloc. Ooh, I didn't calloc. Right. That could be why. Because if it's not seeing nulls, but seeing some random garbage pointers, then it might be trying to read them, and then there's no like. Oh wait, that's the same test. Sorry. Let me get rid of all of you. Let me bring it back to 5, 1, 2, 3. No. Yeah, make you 12. How come there's no tabs? I swear I put tabs in places to make it like easier to read. Like resizing. Oh, it didn't happen. Did I not put it for total size? No. Okay, get rid of you. Just get rid of the print statements. I have utmost faith that this will work. Fair enough. Okay. Aw. 145. It's this kind of thing again. To me, that wasn't a problem. Loaded a misaligned address 0 for type HT item which requires 8 bytes alignment. Undefined behavior in this place. Does it say the information anymore? Okay, fair enough. Okay. Alright, we'll debug it. I don't think I'm seeing anything. Hash equals hash. So wait, let me just see. If I just completely comment this out and go again, is it fine? No. But it seems to be relying on the same misaligned address on that guy. It might not be identical, to be fair, but it is about this particular hash table item, which requires 8 bytes of alignment. And where is the error this time? 165. So 145 and 165 both involve trying to access a particular index and wanting to check if it's null. Particularly, they say 165 character 13. Oops. So the start. This is character 13. This is character 13. And then here, in the second time around, was also character 13. Which is, yeah, so like just the start of it, I guess. But that might not mean anything, I'm not sure. 165, character 13. Yeah, the start of this. Segv on the unknown address. An unknown address. Wait, what was the thing I commented out again? Was it the... Oh, this thing, okay. Why would this go wrong after the... I reckon it's still the resizing. I think I did something strange. Okay, so now I'm callocking, which means everything goes to null at the start. I've made the size so that it's double, and I've made so that the size of thing... I made sure that the size of thing is HT item star, because I want that many items, yeah, where each one has a size enough for a pointer, because the array stores a bunch of pointers to hash table items. Okay. Total size is that guy, is the total size of the HS multiplied by 2. The number of elements is purely the number of active elements in the original hash table, and the number of active is the number active. Okay, I back this. For int I is equal to 0, HS total size, going through every single slot. If it's a null thing, continue. If it's a tombstone, then free it, and then continue. Else index equals HSHT, get the hash set, look at its table, get the particular index that we're up to, and look at the hash value, and mod it by the size, getting the appropriate index value. HT item equals HSHTI, getting that particular item from this place, that particular address, which would not have been freed, right? Like, I didn't free it. I only freed it if it was a tombstone. It's not a tombstone, so should be good. For int count equals 0, count less than HS new total size. Then we do our linear probing. This is all this is. If the index that we're up to based on our modded result. If it's no longer valid, set it back to 0. If HSHT index is null, if we found a slot that is legit, then we can put the item there and we can break out of the inner for loop. Otherwise, we should increment index. Yeah. Break out of the inner for loop and then go to the next slot in the old hash table. HS and U. I mean, the fact is it's only throwing errors after we resize, I think. Actually, here it didn't even resize when it threw an error at 145. 165, same thing. Oh, I know why. Sort of half my fault and half gravity's fault. You have to reassign everything, don't you? Because you could potentially be getting a new address, couldn't you? Wait, actually, does hash set exist return anything? Hash set returns boolean, so I don't have to worry about that. And then here, delete as well. I shouldn't have to worry. Yeah, okay. But when you add specifically, I'm a dumb plum. Okay, I thought of that when I was typing out these, or then when I wrote the main function, I forgot. Do I not? Maybe I don't like that. Would I prefer double pointer? Provide the address of the pointer? It's a bit annoying. But perhaps not so annoying as having to reassign every single time you make the call. Yeah, so basically I was using after free. I was trying to, because when you resize, you free the old guy, but I wasn't reassigning, so I was still using the old guy, the old address to try to do things, and then there was causing problems. Hash set star HS into key. So yeah, if I do it like this and have the address of this guy, then I can be like, look, I want HS. I want the address that HS points to be this guy, and dereference, bonk, bink, and then I can be like, so this is the HS address. Ugh. Hold up. So then hash set HS is equal to the dereferenced HS address. So then I don't need to dereference anymore. And then HS is equal to HS resize. And so and then I can be like HS address dereference, the value of it should be the actual HS, the new HS. And then when I use HS, I'm using the new address if needed, or I'm using the original address if this never happened. And there's no need to return anything because it's being sort of changed in place. Yeah. What? Why did it do that? Okay. Whoa. Okay. So yeah, all that happens. Let me think about this. Hash set add. It's void because you pass in a double pointer, which means when I call it, actually needs to be the address. Which is maybe looks a bit weird, but I think I prefer that because at least we'll come up with a type error if I do it wrong, you know. Here it just failed silently. Okay, cool. And then, yeah, try this real quick. Oh, I messed up. Oh yeah, of course. Because it's void now. So no need to return anything. Just return HS add. Any return HS? No? Okay, should be good. Come on, man. Is that like a... It's changing sometimes, that's interesting. 6229. Oh, but this is about this resize, so there was something wrong. Else if hash set hash table I tombstone. What's wrong with that? Am I not initializing it originally? When I create an HT item, like this, I set the item to false, right? Yeah. So, load of value 64. Is this like the size of it? Or why is it called it a value? It really seemed to half work. Okay, I'll go for like 10 minutes and then I should get rid of this. Not this, sorry, this. Hash set delete. Hash set exists, hash set add, but no, it's literally me just checking a tombstone. HT item double pointer. So when I access, I get the pointer to an HT item. This is 4 bytes, this is 4 bytes, and this is 1 byte, right? So are we cool if I do that? Is that fine or what? What is the size of... The size of Boolean must be... Is it 8 bytes? Okay, good. For some reason I thought there was like a difference between... Ah, interesting. Okay. Um, for int I equals 0, I is less than hs total size. If hs at t I is equal to null, continue. Else if hs at ht I is a tombstone, then free it. I just want to free it. Oh, wait. No, that still doesn't make sense. I'm only resizing once, so... And I set things to null if... Oh, man. HSHTI equals null. Else if HSHTI, the tombstone, is true. Address of right, let me just check something. One, two, three, four, five, six, seven, eight. Just to clarify, if I use the other sanitizer, is it... Was that, like, not a problem? Oh, that was a problem. Okay. Hash set resize. There's no line numbers though, right? There's never gives line numbers, right? In wrap calloc. Oh, maybe it's... Wait. No, I'm confused. From main? I think it's just explaining where the address came from, is that right? I'm so lost. Hash set resize. Heap buffer overflow. Which means I'm reading past the heap, right? I'm reading past something. I'm reading beyond what is illegal. So maybe I'm not... From B naught to D naught, that's like... something. 2 more digits in the 8 power of 1 section. So that's 16 bytes, is that right? Which maybe makes sense because if they were put contiguously, I think the struct might be 16 bytes big because of the whole padding thing. This takes 4 bytes, this takes 8 bytes, this maybe takes 9 bytes, but then to make it lie on address things, it pads it to 16. Actually sounds like a lot. You double the size of the struct because of that? Malloc size of hash set. Calloc. Total size is equal to total size before. For all the elements. Cool. Very good. Here we are. I don't think I'm getting it right now. I'm tired. If HSHCI is equal to null, continue. I'm so confused. Okay, wait, let me try and access other stuff. Like key. Yeah, but it's wrong. Because 40 should be there. I never delete the 40. 12 is there, 6 is there. No, 6 is not there, sorry. But 5, 1, 2, 3 is there, then 5, 1, 2, 3 should not be there. So something is severely broken. You have the abelian. Wait. Why is this print this twice? There's something weird going on. I don't know what I've done. This for loop runs once, right? In the whole program, because I only resize once. That's why this prints once. And so key, like the 1,000 thing, or billion thing, sorry, should only appear once in the array, in the entire table. So why is it appearing twice? Key of the current item is 1. Maybe I can think about this. Hang on. 1, 2, 3, 4, 5. The first 5. One, 2, 3, 4, 5. Okay, hang on. Yeah, so as soon as it gets to 6, the number of elements, which means I've inserted 6, I'm trying to insert the 7th. 1, 2, 3, 4, 5, 6. I've done all these 6. Okay. Which makes sense that it's seeing these numbers, but why is it seeing some of these numbers twice? Specifically, U2. Don't believe that should happen. I have no idea if that has anything to do with the other bug, but it shouldn't happen. So, yeah. Let me look at the addresses as well. So the address that is being stored, I think, in the array, it's yeah, so it's identical, right? OX104C5, yeah. So it's the same thing. So I'll say table index equals I. Something really dodgy is happening. At two different table indices, I'm getting the same. But how am I even able to insert something twice? Like, my add function didn't have two insertions, did it? Like, when I added the abelian over here, it was the third thing I added, so I wouldn't have touched the resizing at all. Hash equals, I get the hash. The already existing shouldn't happen. Chosen index for key equals to key is this index. I feel like I've just forgot to update something. Num active, num elements. The hash set hash table index is equal to the item that we've just created. Okay, here we go. Hash is 12, which tells us that the thing is 12 as well. Hash is 12. The start is 4. Chosen slot is 4 because there was not going to be any collisions. Start is 1. Wait, what? Hold up. What? Adding key equals. Adding key this. Hash. Oh, okay, no, we're fine. Hash is 1. Start is 1. So chosen thing is 1. Start is 0. Because I guess divisible by 8, fine. Is 0. 40. Hash is 40. Start is 0. So the chosen index is 2 because both 0 and 1 were occupied, so it went to 2. 27. 3 is 27. 5 for 5. Also 3. So it's chosen 5 because 4 and 3 were both occupied, so it's chosen 5 despite the start being 3. Adding this guy in the hash set num elements equals 6. So we're getting full now. Going to resize. When did this ever happen? When? What? Like, what? Adding key equals 12. So this chosen index was 4. And the chosen index was 1 for 1. Chosen index was 0. Chosen index was... Like, why do they all... There should be 2 empty spots or something. Like, why are they all there? What is going on? Like, it's not even denying the fact that it's the same address. Like, this billion and this billion are coming from the same place. But apparently, index 6 and index 0 both have that address. Why do you both have that address? You're callocked originally, so everything is nulled out. And then I'm supposed to be very carefully adding things in, and it almost seems correct, except it's not. I gotta go. Oh man. Okay. One more time. One last push. Come on. I gotta use the debugger actually, but I feel like that would take like proper time, so I don't wanna see if I can cheaply get it. But it seems like it's not happening. Int index equals start. Order exists equals flat. Why am I looking at this? Oh no, this is the add. Okay, wait. For int count equals 0. Do I like silently accidentally add something? Like push it in two places? Int index equals hs total size index if the index has gotten, just say greater than or equal to, just for redundancy's sake. Then set the index to be 0. I don't know why I'm putting braces. I'm just like paranoid that something dumb is happening with the scope. If it's a null, if this address is a null, because we haven't used it yet, because ht was callocked when we init it, right? When we init, where's the init function? When we init, yeah, ht is callocked, so everything's nulled out originally, and it will only be not null if we do some kind of insertion at some point. Yeah. So for all the slots starting at the start that we're hoping to get, if index hs total size, then set index to be equal to 0. And then from there, if the hs ht index is equal to null, or hs ht index is a tombstone, then break out, because we are able. In this case, I'm not deleting anything, so there won't be any tombstones. We'll only break out if we find a legitimate empty spot. And that seems to be working. Like, you know, the keys, the eventual chosen indices seem to make sense based on this logic. So that's cool. We break out. If it already exists based on this flag, then return. Maybe it is. I mean, wait, this was the change, right, that I made. So it must have something to do with this. Oh, it's getting too convoluted now. I tried to make life easy, but might have ended up making things insanely complicated. Let me just undo it so that it goes back to the... Did I make a lot of changes since? Hopefully my memory is good enough. So no double pointer. Okay. Let me just check this real quick. No, it's still not working though. Like, it's still wrong. Even when I had it like this, so that must be the problem. Alright, I'll stop there and I'll figure it out later.